Okay, let's talk about exam number 2 is this Thursday. So just like before, at Blackboard there's an exam prep folder called Exam 2, and you can find the Comprehensive Concept and Skills outline. So there's nothing on the exam that isn't reflected somewhere in that outline of things you should understand and know how to do. And then web work is up, and I highly recommend, this is a good way to study, okay? And you're earning yourself bonus on the exam. If you get them all right, it's something like 3 or 4% just added to your exam, okay? And then proportional from there. So if you get half of them right, it's at least 1 or 2% added to your exam score, okay? But it's beyond the bonus, it's just a great way to study. It's just kind of throwing questions at you that you should be able to do based on what we did, but they're from a different system, so they might be worded differently, and this really tests your understanding, okay? So highly recommend that you work on web work. Okay? All the assigned homework and worksheet, of course, is important. I'll organize the top hat questions and make sure those are available, the ones that pertain to exam 2. There's also on Blackboard, where you get the review outline, there's an archive of quizzes from past semesters. So if you still want more practice problems, those are good too. Okay, don't forget the Pathways Tutor Center. It's open Monday through Thursday, 9 to 6. It's also open Friday, but I'm guessing you probably won't be in there on Friday. But Monday through Thursday, 9 to 6. It's ECA 216. That's right across the street from the bookstore. Right across the street from the entrance to the bookstore, 2nd floor. Okay, my office hours are 10 to 12 Tuesday, and in fact, my office hours on that Tuesday are in there, but there's a sign on my door pointing you down to the end of the hall. And then Thursdays at 2:30. Also, I'll be in the testing center on Thursday at 1 o'clock for an hour. So from 1 to 2, I'm in the testing center, and then my office hours after that. And then you need to be in the door by 6:30 to take your exam. So anytime you can enter between 10:30 and 6:30 to take the exam, and you need your Sun card. So enter the testing center before 6:30. You can work till something like 8:15. You need your Sun card, just like before. And that's a PSA 21 basement. It covers modules 4 and 5. 4 is most of it, because we spent about 3 weeks, 3 or 3.5 weeks on module 4, which is exponential growth, exponential functions, and then just this a little bit on polynomial functions and the covariation, right? Looking at how the quantities change together and making the graph. Bottle problems, me walking back and forth, that kind of stuff. Any questions about your exam this Thursday? Take advantage of the tutor center. It might not be a perfect setup and situation, but it's in terms of getting help with this course, besides talking to me, it's the best there is to offer on campus in terms of getting help with stuff from this particular curriculum. Are we good? So what I want to do, just to see if we can reorient our minds here, is go to page 206. There's a function on there, k of x.
Which one?
K of x. What number is that? Part C, 1C. So what we talked about before spring break was the end behavior and the Y-intercept. And I just want to review that on this example. So can you find the Y-intercept? And what is that implication for the graph? How does that help us with the graph of the function k? And then the end behavior. In other words, as x gets very, very large positive, what will y do? This is the right end, right? As x gets very, very large positive, we're talking about the right end of the graph. And then, as x gets very, very large negative, we're talking about the left end of the graph. Okay? So ignore the instructions. I'm just picking off that function that's k of x. You can ignore the instructions and what's written on that page. I'm just picking off this function k to ask this question. What's the y-intercept? And what's the end behavior for this function k of x? See if you remember. See if you can do it. So review what we did, or if you weren't here, talk to the person next to you and see if you can make heads or tails.
Yeah, so be 0. Oh, so yeah, plus 0. Oh yeah, that makes sense. For the x-intercepts?
I'm not asking for x-intercepts. Asking for the y-intercept and end behavior, what we did before. It's a review of what we did before. Ignore the instructions on that page. I'm just using this function. I want you to review the y-intercept and the end behavior.
Well, what's the biggest x-intercept? Ooh, it's a square.
No, it would be huge.
Oh, one. One. 3x squared.
Or maybe not, maybe more than 2. No, it would be
What's the biggest?
to the 4. Then the, no. Yes, no, yes.
3x squared will be
Because you end up with the
18x
negatives.
squared.
Oh, we're going to
Yeah.
oh my God.
So what would you guys say?
So the end behavior, it's like that.
Go on. I have the graph up right now. Yeah, so you're right. You can give it back to the first substitute. Well, I mean, think about it.
We didn't come back, it shouldn't come back up. It should go back. Okay, yeah.
Think about parabola. It looks like it's another third, like that. So the opposites.
So anytime it's hot, it'll go up to down or down to up, and then you try to make it even when it goes like this or this.
So now we need to figure out.
So the end behavior, so it goes
As x approaches infinity.
as y approaches positive infinity,
Yes.
and then as x approaches positive infinity, y.
Can you tell me how you figure that out?
Because there's a negative in front of the 6x.
Okay, so one thing we talked about last time was the difference between factored form and, what did I call it?
Unfactored.
Expanded, or is that what it's called? Expanded. So we talked about factored form and expanded form. And so both of these, really, these questions, Y-intercept and end behavior, are really kind of taken from the expanded form, but I gave you the factored form. Okay, so this here can do. Okay, so this is the expanded form of this same polynomial, but it would take us 10 or 15 minutes to do all the algebra to come up with that. So rather than, how can we still get these same two things, the y-intercept and the end behavior, just from the factored form without finding this expanded form? Should be able to do that. So how about the y-intercept? And how'd you get that? What is the y-intercept? Where what? Where x is 0. The y-intercept, and that the most common mistake is students want to say that that's why the y is 0. But that doesn't make sense because the y-intercept is where it crosses the y-axis. It's the y-intercept. Is y 0 along there? No, y takes on all different values, right? It's the y-axis. What is 0? X is 0, right? X is 0. So we can just plug in x, even though we don't have the expanded form. We can just plug x equal to 0 into this, and we get 0. Okay, so the y-intercept is 0, 0. It intersects at y equals 0. Okay, end behavior is based on the leading term. We talked about Friday before break. The leading term. The leading term is the term with the highest power of x. So here it is in the expanded form, negative 54 x to the 5th. How could we get that without doing this whole thing? We don't care about any of this stuff if we just are answering about end behavior. So how could we get just that leading term from this factored form without having to expand the whole thing out? Remember what we talked about? So it's basically we're taking just the largest piece of each factor. The largest piece here is negative 6x. It's the whole thing. So what's the largest term we get from this? 3x quantity squared, or 9x squared, right? And what's the largest term we get from this? X squared. So to make the leading term, it will be when we multiply the greatest contributions from each of the factors. And that's where the negative 54x to the 5th comes from. Negative 6x times 9x squared times x squared is negative 54x to the 5th. So that's a trick you can do just to get that leading term without expanding the whole thing. Just take the largest contribution from each factor. Anybody have a question on that? So then this allows us to find the end behavior. As x gets very, very large positive, what about x to the 5th? Just x to the 5th, positive or negative? Positive. Then multiply it by negative 54. So as x gets very large positive, what does the leading term do? Gets very large negative, right? Because x to the 5th will be positive, but multiply it by negative 54, and it will be negative. Okay? As x goes to negative infinity, as x becomes very, very large negative, what about just the x to the 5th? Negative or positive? To the 5th. Negative. You're multiplying a negative together an odd number of times. So it'll be negative, and then we're going to multiply it by negative 54. Positive. Okay, so then our end behavior is, as we go way out to the right, this is the right-hand end. So as we go way out to the right, the y value will go down to negative infinity. As we go way out to the left, the y will go up. So here's our end behavior. This is y going to negative infinity, y going to positive infinity, accordingly. Okay, any questions on this kind of review exercise? Anybody have a question? So the rest of it then is, so we talked about, and then, and then the y-intercept would be 0, 0. So those are the two things we find from the expanded form or from the leading term. We get the end behavior. So what we want to talk about the rest of today is what's called middle behavior. So all this is still unknown. What's happening here according to the function? So we call this, since it's the middle of the graph, we're going to call it the middle behavior. Okay, the middle behavior. So the expanded form, because it gives us the leading term, we kind of associate that leading term with the end behavior. The factored form is what helps us really pinpoint the middle behavior. Okay, so I'm going to erase the screen in a second. We'll keep working on this particular function. So, last chance for questions on what I've written up here. Okay, so we can even factor this a little bit further. How can we continue to factor this up here? Negative 6x, that's as best we can do. 3x plus 2 squared. What about that last term? Remember what that is from algebra? X plus 2. Remember that? Difference of squares. Difference of squares, x squared minus 4, or a squared minus b squared is a plus b, a minus b. Okay. So some of you already know what can we right away, what can we get about this graph based on that factored form? What's that? No, we already did the end behavior. The end behavior is from this. Okay, so that's our end behavior. So now looking at this, what can we know about the graph, kind of what's going on in the middle? Okay, so someone said roots, someone says zeros, someone said x-intercepts. Those are all kind of the same cloth. Those are kind of the same thing. So the roots are, so what's the root that we get from x minus 2?
2.
Positive 2. What root do we get from x plus 2? Negative 2. And what root do we get from 3x plus 2? So if you're not sure, you can just take it and set it equal to 0 and solve for x. So we're asking what values of x make the function 0? What values of x make the function 0? So this would be negative 2/3. Any other roots? Any other values of x that make the function 0? Yeah, because of this x here, x equals 0 makes the function 0 as well. Okay, if the x wasn't there, would 0 be a root? No, just the negative 6 does not, just because there's a coefficient there, doesn't mean that x equals 0 makes the function 0. There's got to be just an x by itself to have a root of 0, or x squared or x cubed or something like that. Okay, so we've got these roots, and these are the x-intercepts, or the zeros. So now the zeros, the difference between roots and zeros is the form of it. Roots are the actual x value. The zeros are the ordered pair. But these are twins, right? These are basically the same thing. It's just roots. The roots are just the x value itself. The zeros are the ordered pair. So it gives us all those ordered pairs. So we can sketch those. We got 2, 0, negative 2, 0, and negative 2/3. This is right about there. And then also 0, which was, we knew that from the Y-intercept, but since it's 0, 0, it's also a root. Okay, so those are the roots and the zeros. Now, there's one more thing about this middle behavior, and it's called multiplicities. The multiplicities are the power on the factor. So I'm going to put those here. So multiplicities. So for the root of 2, we have the factor x minus 2. What's the power on x minus 2? 1. So that's its multiplicity. What's the power on this one, x plus 2? Also 1. What's the power on the factor associated with negative 2/3? 2. So its multiplicity is 2. And the multiplicity of the root 0 is also 1. So the multiplicity, so let's actually graph this and see what's happening. Okay, so everyone got the factored form and this table written down. I'm going to erase this. So you've got the factored form and you've got this table right here written down in your notes, and so let's graph it and see if we can make heads or tails of what's going on here. So I'm going to graph this here. All right, so does this have the right x-intercepts according to what we talked about?
Yes.
Yeah, we got x-intercept here at 2, and at 0, and at negative 2/3, and at negative 2. So what was our multiplicity here?
1.
1 was the multiplicity here. What about at 0?
1.
1.
2.
2 here. Those are our multiplicities. So we're talking about x minus 2 to the first versus 3x plus 2. That was like a 2-3 hybrid there. 3x plus 2 squared. That's our multiplicity 2 right there. So what is it about this behavior right at x at 2 that relates to a power of 1 versus right around here that relates to a power of 2? Do you see it?
It crosses.
Crosses versus
It
touching.
crosses versus touching.
It changes direction.
Changes direction when it touches. So what about why this a power 1 and why that a power 2? What is it about powers 1 or 2 that are reflected in the way the graph looks?
Linear.
What's that?
Linear.
Okay, so our linear, x to the first, isn't that like a linear graph? And what does it look like as it goes through at 2?
Like a line.
Linear, right? It looks like a line. And what is power 2? Parabola. Let's zoom in there. See what happens when I zoom in at negative 2/3. What does it look like? Looks like a parabola. And we know, so when the power is 2, that's parabolic behavior, right? That's a quadratic or parabolic behavior. And so the multiplicities show us what the behavior of the graph is near that corresponding root. Okay? So notice, so we had a multiplicity of 1 at 2, and it goes through like a line. We had a multiplicity of 1 at 0, it goes through like a line. Multiplicity of 2 at this particular root looks like a parabola. And then similarly, multiplicity 1, it goes right through. I'm going to start before I forget. This is most recent homework. It's graded. Alphabetized by first name. Okay, so, and then putting it all together. What did we say the end behavior was? As x went to positive infinity? We had y going to negative infinity. That's what we got. And as x went to negative infinity, we had y going to positive infinity. Okay, so that confirms what we had before. So that's everything that we're putting together to create these graphs. So let's do some examples here. Can I mute this here? Okay, so what I want you to do, so here's, sometimes you have the graph and you need to come up with the formula. Other times you have the formula, you want to draw the graph. So, actually I want to do the other way first. Okay, so practice. Here's the, is that low enough? So we're putting it all together now. Y-intercept, end behavior, roots, and multiplicities of the roots. Trying to put it all together to recreate this graph. I'll make that list. So what do we say? Y-intercept. End behavior. Roots or x-intercepts. And multiplicities. Which is behavior near the roots. Okay, and I would, to construct the graph, I would do it actually in this order. I would find your y-intercept, your end behavior, roots, and then multiplicities. Going in that order, and I'll show you in a second. Come up with as much as you can here. Okay, don't just put it in your calculator and graph it and then draw the graph. The point is to doing it just from what we've learned. Okay, let's do this one together. So what about the y-intercepts? How did you get 2? Yep, we want to put in 0 for x. So when x is 0, we're going to get 1/8 times -1 cubed times 2 squared times -4. I'm always off the screen. Okay, do you see? So the y-intercept is where x is 0. So you just plug in x equals 0. And we get this is going to be -1 times 4 times -4 times 1/8. Is it 2? It's 2. Therefore, y-intercept is 2. End behavior. In order to do the end behavior, we need what? Leading term. So the leading term is going to be 1/8 times largest contribution from this. X cubed times x squared times x. Take the largest contribution from each factor. So we get 1/8 x to the 6th, leading term. And instead of memorizing stuff, just do it each time. So as x gets very, very large positive, we go way out to the right. X to the 6th, positive or negative? Positive, 1/8 x to the 6th, positive or negative? Positive. So as we go way out to the right, this thing is going to go up, like that. Okay, as x gets very, very large, negative, left end. What about x to the 6th, positive or negative? It's an even exponent. Even though x is negative, multiply it together an even number of times, it becomes positive times 1/8, positive. So over here at the still off the screen. Over here at the left end of the graph, as x goes to -infinity, y goes also up, positive. Okay, what about our roots? Where are our roots? We get a root at +1 there. These are values of x that make the function 0. What value of x makes it 0? -2 and +4. Multiplicities. Let's start with +4. What's the multiplicity here at x equals 4? 1. Multiplicity at x equals 1? 3. We didn't talk about that one, but it's the same logic. Okay, multiplicity at -2? 2. So now we have to put it all together. We've got our end behavior, we've got our roots, multiplicities. So here's what you do. So as we come here, if we were going to positive infinity here, the first time it's going to hit the x-axis is going to be at 1. And what's it going to be like when it goes through 4? Like a line, right? It's going to be linear like this. Okay? It's not going to cross the x-axis anywhere through here. So therefore, as it's coming like this, it must start going back, have a low point, and start going back towards this. How will it go through at x equals 1? Okay, it'll cross like x cubed crosses. If you remember from algebra what x cubed looks like. Does it go through linear? No, it like flattens out. X cubed does this. Okay, that's what x cubed looks like. It goes through, but it flattens out. Okay? And then it's going to go through our Y-intercept. So now, at -2, multiplicity is 2. What will that be like? Parabola. Okay, it's going to be pretty shallow, just because the way my scale is, here's x equals 2. So it's going to come through like this, and it's going to do what a parabola does, like this. And then, from there, end behavior. So let's have the calculator do it. This will be a lot prettier. But did everything we say, is everything we said right? Yeah. It's just, we didn't stretch it enough, right? So it's like way flattened, but linear, like a cubic, like power 3, Y-intercept, and then like parabola. Okay, so why don't you try, we're going to do one more example after this, so kind of move fast. Do page 210. Page 210, the whole thing. See if you can motor through this in about 4 minutes. Page 210. Don't use your graphing calculator. See if you can do it without it. It is. Yes, -1/2. That's right. -1/2. C, ignore C. Ignore C. Just ignore C. So A, B, D, and E. Ignore C. We didn't do that.
Is that like Y bounces or Y goes through?
Yeah. Okay, one more minute on this. See if you can get it in 1 minute. Okay, Y-intercept. Negative 4.5?
Yes, sir.
Okay. Okay. End behavior. As x goes to infinity, as x goes to the right, what does y do? It's going to go down. As y goes way out to the left, up? I agree. Okay, so we got the end behavior, we got the y-intercept. How about the zeros or the roots? 3 and negative 1. What about 0? No, it's going to go through this, right? Okay, how is it going to go through at 3? Right, it's multiplicity 2, so it's going to be like a parabola. Is it going to be pointing, based on this end behavior right here, is it going to be pointing up or down? Down. So you combine this end behavior with the multiplicity at 3. To have a parabola looking thing, okay? And this makes sense because it's going to come like then down here to the y-intercept. And how's it going to go through at negative 1? Straight through?
No.
Like a cubic flattens out. Something like that, and then? Maybe this one will be a little better than last time. No. I can fix that. It's just because of the scale, so. What's that?
Y-intercept.
Here?
The Y-intercept? That's okay, it's not a root.
Yeah, I made the mistake of assuming that this was the minimum, that the y-intercept was the minimum. But we didn't talk about what it looks like through the y-intercept. We never mentioned that. It's only the roots that have multiplicities associated with them. The y-intercept doesn't have a multiplicity associated with it. So, yeah, and I came through and I assumed it was the minimum, and that was a bad assumption. Okay, so the other type of example would be, given the graph, you come up with the equation. Given the graph, you come up with the equation. See what you can do. Go. Yeah.
I guess.
So you go through each thing. Say x is very, very large possible intermediate term.
X minus 1, right?
That's right. So x is very, very large positive. What is x to the fifth?
Yeah.
I'm sorry. That's
Oh, well, I guess.
That's right. That's right. Roots are just very large positive. When x is very, very large negative, what is x to the fifth?
Well, x is negative.
Negative. Say boom.
Your X
Yeah. Wait, why do you have plus?
Okay, so your roots are -1, 0, and 2. What's the associated factor with a root of -1?
X plus 1.
X plus 1. And what will the multiplicity be on that? 1. Okay? At 0. X squared. So the factor just is x, and the multiplicity is 2. Okay? Factor here. X minus 2. Multiplicity 1. So we can start building this as x plus 1 to the 1 times x squared times
X minus 2.
to the 1. But we could multiply this by any real number and all that stuff would still be the same. And so this is what this is for. So with this information right here, we can figure out what coefficient we have that would do it. So when x is 1, y is -4. So we should get an output of -4 when x is 1. See what I did? If you plugged 1 in for x, the result ought to be -4. And so now what's this coefficient that would make that true? What coefficient would make that true? So over here we get 2 times, so -4, 2 times, so this a is +2. So when a is 2, this will give us a y value of 4. So therefore the function is see if that's right. Is that what we said? Okay, written homework. There's written homework for Wednesday. And your test, the exam is Thursday, don't forget.